Number 11 part E says to use the results in part C to determine the gradient and the y-intercept of the equation of the line of best fit. It's called linear regression. Write the equation in the form S is equal to MH plus C. So for those of us who have done college algebra 1, we are familiar with the general form of a linear equation. Y is equal to mx plus c. Okay, in that case, y is s and x is h. Okay, so we're going to formulate an equation to, to represent, to describe the relationship between hours of study and score. Hours of studies is x, score is the s. So we need to calculate m. Okay, so we go to the list of formulas to see how we can calculate m using linear regression. We are all familiar. M is equal to y2 minus y1 over x2 minus x1. Okay. But here now, m is calculated differently for linear regression. Okay. It's kind of want to look similar to y2 minus y1 over x2 minus x1, but it is fundamentally different in a lot of ways. So you go to the list of formulas. Okay. And here is m. Linear regression for the gradient m. M is equal to n times the sum of xy minus the sum of x times the sum of y over n times the sum of x squared minus the sum of x all squared. Now, when you look at the m formula and you compare it with the r formula, you realize now the numerators are the same. And here now, this part, the n sum x squared minus the sum of x all squared, is also identical. And we call these numbers A and B. Could we call A, B, C? So M now for linear regression in this class session can be simplified to A over B. Okay? Because A, look A there in the R formula, B, look B there, identical. Okay? And the question says, use your results in part C. So we can go back to part C. Okay, let us take a snapshot of this. Yeah, look, A, B, and C right there. I took a snapshot of it to send it to you all. Here is M. To find the gradient. Paste it there. And in the help that is given already, it says, since the values are the same as in number 11 part C, that's not number 10, number 11 part C, we can apply the formula M is equal to A over B. Okay, so when we go back to part C, A is 19,560. B is 16,452. So we can just copy this. Okay. Can paste this right there. Okay. So go back to your A and B in your assignment. Okay. I can just delete this. Okay. Right. So hence now, M now, let's go to insert equations. Centralize this. M is equal to a fraction. Well, let me try to see if the fraction will work. Like how 19560 fraction. It works too. So just by, that the fraction line, I don't have to go to fraction and look for fraction. 19560, put the fraction and just tab and look, the fraction automatically pops up. Okay, and then you have 16432. Okay, A over B. Okay, because the formula for M, it was derived from the formula for R. Okay, so this is why now in this course, the linear regression will always come after a correlation. I will not make you recalculate again all those values. So you can use your values from the product moment to continue with the analysis. 1.19. okay, equal to 1.19. Okay, bear in mind what we are doing, we are trying to construct an equation in order for us to forecast. Bear in mind, a linear equation, M is the gradient and C is the y-intercept. H and S are the variables, okay? It's like the X and Y. Okay, find the gradient. We have just found the gradient to be 1.19. Now we're going to find the y-intercept, okay? So the y-intercept now, formula for the y-intercept. Let us go back to the list of formulas. The formula for the y-intercept. C, here is C. C is equal to the sum of y minus m times the sum of x over n. Okay, and all of these values now in C, we have already obtained these values in previous calculations. Okay, so we can use our results in number 11 part C also to find m. Okay, so therefore m now is equal to 1.19, but C now centralize this. C is equal to, we need a fraction, so we can just put the sum of y. We go back to our answers, our results in part C. The sum of y, we got sum of y to be 414. Okay, 414. Let's go back inside it. Right. 414. Okay, the sum of y, n was 7 minus m. Okay, m, we got m to be 1.19 times the sum of x. The sum of x is 215. Okay, and that will give us C. So let's just put that in our calculator. C to be 22.59. C is equal to 22.59. So therefore now, since we have found M and C, we can complete the equation. Y is equal to mx plus c. Y is equal to 1.19 x plus c, 22.59, and s now will take the place of y. H will take the place of x. So therefore now we have S for score is equal to 1.19 times H hours of studies plus 22.59. Okay, so here's the equation to describe the relationship between hours of study and score using linear regression.